Howdy. Welcome to PA4. If it looks like I'm looking at something else, yes, I am looking at the screen, but basically I'm trying to talk to you. But I'm gonna step through PA4 real quick, and this should be a complement video to the main one, which will be provided to you, just like previous PAs. But let me go over the PA, like what you need to do for the PA, real quick. Okay. So first of all, we no longer have FIFO requests, so now we switch everything to TCP request. So you will have a TCP request channel .cpp and TCP request channel.h. So the first one, .h, this is the header file, so there's nothing really you need to change about it. Everything is provided to you. You can read about it, like what does the TCP request channel constructor does, and you need two versions of it. You can see this one is for accept, which I will talk about it later, but this one is for the initial established of the channel. So, you just read over it and think about it. And of course, just also look at the other video and you should be fine. Okay. Okay, so here's your TCP request channel.cpp. I recommend having a picture of the socket. This one is for Java, but it's exactly the same. It's a TCP standard TCP protocol, so it's a standardized protocol. So regardless of whatever language you use, they should provide the same experience, at least for Java and CPP and Python. That's for all I know. Okay. But you can see we have two sides in the constructor, right? Because it depends on the constructor. But if the IP address is empty, right, then that means it's for the server. Else, if there is an IP address which is given in a string format, then you have to pass in the IP address. Okay. The reason is the goal is like this: the server will establish itself as a server, of course, but the client will then try to establish connection with the server by connecting to the server IP address. So the server doesn't care what IP address from the client is, at least for this program, but the client needs the server they need the server IP address so to be able to talk to it, right? Else it doesn't know where to go, right? So you have right here. Let's go to the server first, okay? So you have 4 steps in the constructor: socket, bind, listen, accept, okay? And in the client, you would have socket and connect. So let's see. You have IP address is empty right now, so that's for the server. You set up the variables. So I have a struct sock address in. This is for like providing information needed to establish a socket. Okay. So then you create a socket right here using the socket. Here I given you the actual socket system call. You have in domain, in type, and in protocol. I highly recommend you go on the man page and look about it a little bit more. But you pass in the AF INET, right? AF INET is the IPv4, and sock stream is TCP. I think there's another one for UDP, but I don't remember on top of my head. But sock stream is for TCP, okay, which is what we need for this one. And then for the last parameter, which is the protocol. If you for the sake of this assignment, we make it a 0. For some other special type, you might make it other value, which depends on how many protocol you need to support. But for this one, 0 would be fine. Okay. And let me zoom it out a little bit. Okay. Oh, right here. Let me zoom it back in. Oops. Okay, so then once you create a socket, right, now it's an empty socket, it doesn't do anything, it just sit there. Now you have to bind that socket to a specific machine specific info. So right now it's just generalized socket. It doesn't do anything. It doesn't attach or anything. It just sit there. Now we have to attach it to bind it to system-specific information to know where exactly the socket should go to, right? Okay, so it's like a file descriptor. This, you can think of socket as a file descriptor. It just sit there. You need to use other system calls to be able to make that socket or that file descriptor useful. So in this case, you want to bind it to necessary machine information of the SOC address info, right? So I highly recommend you look up, I think the other video might provide you with all of these. So basically you use the SOC address end struct. You pass in all these information. So address families IPv4, use the IP address using current IP address. So for you use you need to pass in the what IP address it should attach to. In this case, we don't care what the IP address is. We want to attach it to the current IP address of the server. Connection port, what port you want to establish. Let's say you want port 10,000, then put in 10,000, right? So that's why we have a port right here as a string. Okay, and then convert short from host byte to network byte order. Okay, so again, if you read about order, we have big Indian, and then small Indian, little Indian, and then big Indian. Okay, you have to convert that short from the host byte. So basically, you need to convert this from the host byte order to network byte order. I'm pretty sure it's a connection port to that, so that you will be able to read. And then you bind. So now, after you pass in everything to the struct, now you can just use this to attach the SOC address file descriptor with the information you just pre-written, right? And I think, yep, that's all. Yeah, and then this is struct length is how long the thing is, so you can get the length of this. And then you listen. Okay, so now once you establish everything, now the server just listen, right? It just sit there listening to some incoming connection. Okay, so now it's know where to listen to. It will now start listening. And then you have an accept connection. So now what happens if you listen and then a client program want to connect to the server. Say, hey, I want to establish the connection. Well, you need to use the accept to be able, hey, I accept this connection or pick up the call, right? But because of the structure of this program, we're actually going to write this function in a separate function, right here, accept connection. Okay, and I will explain it in a bit. Okay, so now for the client, you do the exact same thing. For the first one, you just establish the socket. You generate the same thing. To generate the server info based on the parameter. So you need to write the server info down so that you can connect to it, right? So you need the IPv4. It's established for IPv4. The connection port, again, is the connection port. So if you establish a connection port on the server to be 10,000, then you also put 10,000 here in the connection port. So now they agree on which port to connect to, right? You convert the short from the host byte, again, the same exact thing as the previous one. And then you convert IP address C string to binary representation for SYN address. So SYN address, which is part of the struct, server info struct, the socket address and struct, it needs to convert from the C string, right, to a binary representation, right? And then you connect. So now you're done with socket, you create a socket, right? Now you just connect to it, right? So in this case, you just call the connect. It needs the socket address. It the struct to given the server information, and then the length again, like how many bytes is that, right? And then that's it. That's all the step you need. So once you follow this idea, and then you should be able to create and establish a connection, right? Okay, so once you create the TCP request for this client, right? When you call the constructor, they should immediately be able to. So then the server immediately be able to accept that connection. It's connection request. It's established a connection request the moment you call the um, the TCP request channel for the client. Okay. So now we have another TCP request channel constructor, but this one only have the socket address, right? So this means the let's say assign an existing socket to an object socket file descriptor. So let's say you already established a socket, right? AKA establish it via accept connection. Then you only need to pass that socket in to the socket data member in the socket object. Okay. And then for the destructor, all you do is to close the connection right here, end of life. So make sure you close it. So you just call the close socket, and I think close is what? Yep, it just called the file descriptor. Yep. So that's it. So the current member. So I think you gotta do it like this. File socket FD like that. Okay. Okay, so now you talk about the accept connection. Now we do the last step to be able to establish connection between the client and the server. So what do you do? Well, you accept the connection. So accept connection, again, you create this, and oh, sorry. So you need an integer somewhere to be able to accept connection. So like a variable to accept the connection or accept the file descriptor. Socket file descriptor for the accept connection, okay? And then you accept the connection by calling the accept. Here you go. That's the exact same thing, right? You just accept the request, and then you return the socket file descriptor, so it knows where to get into, right? Like what socket is available for connection, right? And then for the C-write and C-read, again, now you have write and read right here, right? And then you just get the number of, you have a variable to contain a number of bytes to read, right? And then you read from the socket, and then you return number of bytes that you read. So you read using, read, and then you get the socket, and then you get the buff, and the count or the size of the buffer, or the size, how many bytes you want to write or read from, right? And then this one is the same thing, write. It's exactly the same as this, but instead you use write. That's it, right? So that's all you need for the TCP request channel, okay? And then for the client, actually let's talk about the server first. The server, all you change here is that you have to replace every single Actually, no, they already pre-written. I forgot my year. We have to like rewrite the whole thing, but they provide you nicely this time by replacing everything for you, so you don't have to think about it. All you need to think about is you go down here and you do the fix me. So here's what given to you. So open the socket with address empty. So in this case, it's to indicate that it's server. So in previous FIFO, you have an enum that specify if something is a server or a client, but this time you just have to provide the address or empty address to be able to say, hey, this is the server. Okay, and then enter an infinite loop right here. You have an infinite loop right here, and call the accept connection and the second TCP constructor, the one that we talk about, and then dispatch the handle process loop. So again, you call the constructor, you pass in the port and the given port and empty address, and then you accept the connection using the channel, and then you create a new channel with the accept connection socket. The socket is already established. Again, you use the second TCP constructor. Okay, and then you dispatch a new thread to handle process loop. So you basically literally call the thread function again, and you pass in the handle process loop function pointer or function name, right? And all the parameters that go with it. You also, since the main function thread is not blocked, so in this case it doesn't care how many it can accept multiple connection at once, right? It doesn't have to wait, right? So remember that for thread you need to use either join or detach to be able to prevent errors, right? Because you don't want, something to finish before the main thread. The main thread to finish before other threads. So in this case, you use the detach instead of join. So thread, call the function, and then dot join. Dot detach. And that's it. That's all you need for the server. And then for the client, all you need is everything is preserved. You use everything from PA4 or 3, but now you don't call the fork anymore because you don't call the server anymore. You have, because they are two different processes now, and they can't really, you have to call the server and the client separately. So you can't really use fork anymore. Okay. So then you just establish the connection TCP with the host name of the port for the control channel, and then for each channel you just get that. You just get the TCP request new channel, new TCP request name, and then you just push back. And everything else you keep them the same. So nothing changes here. Okay. And then at the end, make sure you don't wait anymore because the server actually don't quit. The server actually doesn't quit. What you actually have to do is, actually there's no way to quit it. It would be an infinite loop forever. So you just have to control C the server and it dies. And that's fine. Okay? And yeah, that's it. That's basically the whole PA. You can see it's actually not bad. It's about, this one, no line of code. This one maybe 20, 30 lines of code. This one is like 6 lines. This one is like 3 lines, and even less lines than before because now you comment out a lot of the codes, right? So it's 20, 30 lines of code. It's quite harder to debug in some sense. So make sure that when you debug it, you can't really do GDB on it because you now have 2 separate things. But one more thing you need to know is that when you run manually, you have to change the port constantly. The reason is, let's say you open a port 10,000, then you control C. It takes a while for the system to remove the port. So if you run a 10,000 and then you run it again, it won't work because it just sat there, waiting for the port to die out. So you have to change to port 10,001 the next time you run. So you have to, be a little bit more careful when you run things because else, it would cause this socket is already established. You can't really reestablish it until a little bit later. Okay. So that's it. Good luck on your code, and if you have any question, let me know.